Okay, now it's time to talk about motion in both the horizontal direction and the vertical direction at the same time. And so we're going to call this a trajectory. So if we'll start by looking at the formulas that we're going to use. So that we have the horizontal motion, and the first one is going to be the how fast equation. And then underneath it is the how far equation, and then underneath that is the hybrid equation. But since we're dealing in both horizontal and vertical motion at the same time, you notice I had to put more subscripts. So I said, what was the initial, or what was the final velocity in the x direction? What is the initial velocity in the x direction, and so forth. And then in the other column, we have the formulas that we would use to explain something that's moving up and down. Notice that instead of the letter A, I put in the letter G for gravity, and then also I put a subscript Y on those so that we have the final velocity of an object in the Y direction, and then the initial velocity of the object in the y direction. So notice that we've got like 6 equations here, and so you might think that it'd be impossible to talk about motion in the up and down and the sideways at the same time. Well, it's not quite as bad as what you might think, because let's look, for example, at this picture here, which is showing a table, and then you've got this ball that has a certain speed. So let's say v is equal to some constant. So that's the initial speed of the ball, and it's rolling on the table, and then it's going to roll off the table, and then it's going to have some kind of a trajectory like that, and then it's going to hit the floor. So the floor is down here. Well, let's take snapshots of what the ball is doing. So the ball might be here, and then the ball might be here, and then the ball might be here. So let's say that this is like 1 second after it rolls off the table, and then this is 2 seconds, and then this is 3 seconds, and then down here is 4 seconds. So do you notice anything unusual about the sideways velocity? Not the up and down, but just concentrate on what is it doing in the sideways direction. You should notice it's moving at a constant speed. Whatever speed it's got right here, that is the same sideways speed that it has here, and the same sideways speed that it's got there. So I'm drawing this arrow the same size as that arrow, and then this one here is going to have the same speed, and then this one is going to have the same speed. So the speed is constant in the sideways direction. Why is that true? What was Newton's first law of motion? An object moves at a constant speed as long as there's no forces acting on it. So are there any forces acting on this thing in the sideways direction? No. So whatever speed it's got when it's rolling on the table, that's the same speed it always has when it's going in the sideways direction. So what does that mean? So that means that if we go back to, let's use our how fast equation. In the sideways direction, there's no acceleration. So that very, very first equation under horizontal motion is just going to be that the final speed is equal to the initial speed, which was whatever this number is, what that constant number is. So that simplifies that formula greatly. So now we know it always has the same speed going sideways. Now let's take a look at what it's doing going up and down. So don't worry about the sideways motion. Only worry about what it's doing in the up and down. So initially, just as it comes off the lip of the table, it has no speed going up and down. But then it starts to have a little bit of speed, and then it has a larger amount of speed, and then it has the largest amount of speed. So can you see that it's falling as though it was not moving sideways? Just take the ball and drop it straight down, and you would notice it has 0 speed when it's in your hand, and then after a while it's got a little bit of speed, and then more speed, and then more speed. So we can do trajectories by breaking it up into 2 motions, going up and down, and then sideways motion. So we already know what the sideways motion is. It's constant velocity. What's the up and down motion? So if we go back to our formulas, let's look at the how far equation going up and down. And so that equation is just going to end up being the distance that it drops, so that's going to be r sub y. Now, what's its initial speed? 0, because it hasn't started to fall yet. So that means it has 0 initial velocity in the up and down direction. So all that you got left is the 1/2 g t squared thing. And so if you know the height of the table, then you know the r. And then you can solve it for the t. So now you know how long does it take to drop straight down. So what can you do with that? So now you can take that time and you can figure out how far it would go sideways by using the horizontal motion, the how far equation. So that one would be the distance that it travels in the x direction, the horizontal direction, is going to be equal to the speed initially times time. So we're going to take this time, whatever that is, and we put it right there. And so now we can calculate how far would it go sideways. Well, what about the other part? What about the 1/2 at squared? Well, it's going at a constant speed sideways. So what's its acceleration? 0. So that part of the formula is not there. So here we've got this, let's go back, this complicated looking trajectory when all you got to do is use these 2 very simple formulas in order to figure out where it's going to land on the floor. So the connector between horizontal motion and vertical motion is going to be t, the amount of time that it takes. So the way that you do these problems is you solve it for time in the horizontal direction, and then you plug it into the you solve it for the vertical direction and then plug it into the horizontal direction. So it's not really quite as bad as you might think. But we're not going to do it in lab. But if you went on to take general physics, so the next level up in physics, not only would you do something like this, but you might do a problem where you got a cannon and it's going to do this. And you can figure out where it's going to hit. You would even do something where it might go into a hole, and then you would figure out where does it hit in the bottom of the hole. So they do all sorts of crazy things in general physics. Okay, so that is a trajectory. So our final topic for today is to talk about graphing, and we'll do that in our next segment.